All right, a couple example problems. Two straightforward mathy math problems, and then the third example will be more of a story problem, similar to the one in the pre-lesson where there was a dog going up the hill and the owner threw the ball, questions like that, okay? So we've got a parabola and a line. Might be 0 solutions, might be 1, might be 2. How do you do this? Well, you see y equals this and y equals this. That means they have to equal each other. And this is why we've been learning completing the square, factoring, and the quadratic formula. So setting it equal to 0 is always a good move. So 3x squared minus 3x plus 2. And doesn't look like that's going to be too factorable. It's not going to work too well. So I'm going to use good old quadratic formula. Here's my a, b, and c. So negative b would be 3 plus or minus the square root of b squared, which is 9, minus 4 times a times c all over 2a, which is 6. And if I can simplify this, I'm on my way. So 3 plus or minus 4 times 3 is 12. 12 times 2 is 24. So I get the square root of 9 minus 24. So that's negative 15 all over 6. So to simplify this, I get 3 plus or minus, take the I out, all over 6. Now, as you can see, I've got an imaginary number that pops up, which tells me there are no real solutions. So this is not possible. There is no solution to this. All right, let's move on to this one. This one's set up quite easy because y equals y equals. This one, not quite as easy. All I have is one of them that says y equals. Well, the trick there is, might seem painful at first, but you put that into the other one. So 2x minus, almost forgot the parentheses, 2x squared minus 6x minus 8 equals 16. Distribute that negative through there. And I know this is a trinomial, so I'm going to go ahead and subtract 16 from both sides. Put things in descending order, negative 2x squared. Now there's a 2x and a 6x, so that's 8x. And I got 8 minus 16 is negative 8 equals 0. Is anything jumping out at you? You should divide this by at least 2. And I'm going to divide it all by negative 2 because I like my squared to turn positive. So x squared minus 4x plus 4 equals 0. So I look at this and think, hey, can I factor that? And you might try it. So you might say, hey, look at this. X minus 2, x minus 2. So if I was to solve this, I'd get x is 2 for this one, and then I'd get x is 2 for that one. If that's the case, and I graph this, and I get the same x twice, that means there's only one solution. I know it's a little bit weird. It's like, wait, you got 2. Well, they're the same thing. So if I was to plug this in and find my y, I'll go ahead and use the top one. So I'm going to go 2 times 2 squared minus 6 times 2 minus 8. So following PEMDAS, 2 squared is 4, 4 times 2 is 8. Negative 6 times negative 2 is negative 12 minus 8. Well, this is negative 20 plus this is negative 12. So I get 2 negative 12. Now what's the point of plugging that in again? You're just going to get the same answer. So that means you have one solution, and there it is. By the way, if you were to plug this into the quadratic formula, you'd get negative b plus or minus the square root. And if you plugged it all in, remember you get b squared, which is 16 minus 4 times a times c all over 2a. That's not my concern. Look at it. That's 16. 16 minus 16 is 0. The square root of 0, remember that? Means there's going to be one solution, and that's what happened. Okay? Throw that in for free. One more problem. It's a story problem, but don't panic. All right, third example, a little story problem. As always, story problems have a way of intimidating us. But if we can just get the visual image of what it is they're trying to get at, remember what we've been dealing with, parabolas and lines. So there could be one solution, two, or zero. So if we just hang tough with the idea of this, but you can also see mathematically we have a quadratic here, so we know that's a parabola, and we have a linear function, so we're like, oh, this is just a different way of kind of introducing us to a line and a parabola. Now, one thing I want you to notice, they give this to you a little rearranged. So if we were to think, wait a minute, that's the same thing as y equals negative 3x plus 490. Sorry, I got a little ahead of myself. This problem is from Try It, example 3, page 119. It's about a band and the amount of revenue, the money they make, and X represents the ticket price. So, you know, if I charge 10 bucks a ticket, I'd make this much revenue. 20 bucks a ticket, that much revenue. And then the cost of putting on this event is right here. So what we have is y equals 490 minus 3x. And so we've got like two overlapping graphs here. We've got revenue and cost. Cost is the y value here. Revenue is the y value here. So we've got two overlapping graphs, and we're going to interpret that. So if you notice this, we got 490. Now my graph's not going to be perfect, but I'm going to say, hey, there's my y-intercept and my slope. Remember what we said? If the slope is negative, it's going to be down. Now my graph, you know, my units are way off, but all I know is it's going to be down. Now, a lot of times we try to be really perfectionistic, and it's like, wait, is it steep or is it? But remember, we're dealing with a parabola and a line. Our drawing doesn't need to be perfect. Now, what does this represent? Well, this represents a parabola, and if I charge $0, my revenue is going to be zero. So it's going to be something like this. It could be like this, where there's like, well, there's no way you can make any money. Or it could be up like this and touch it in one place. But I'm going to try something and just go, hey, it's going to come up and come down, because it says at what ticket price, maybe it says prices, X, see, X is ticket prices, will the band make enough revenue to cover the cost? So what we're looking for is this space right in here, but we're really talking about the X value from that spot to that spot. So we got to figure out what that is. Well, it would be nice to figure out what these points of intersection are. So there's the twist. There's going to be an XY there. There's going to be an XY there. Now remember, there could be zero solutions, one solution, two. My instinct is there's going to be two, because, you know, if they're asking the question, where does the cost, where is it covered by the revenue where they're going to actually make money? So this has to exceed the whole cost of the whole concert. So with all that being said, it's just a math problem. Y equals this stuff, y equals this stuff. Now the math's going to get a little nasty, but negative 330x squared plus 250x equals 490 minus 3x. Resist the urge to hit the panic button. Add 3x, and subtract 490, whoops, 490, subtract 490, negative 30x squared plus 253x minus 490 equals 0. I got to check something. I might have written one of the numbers down wrong. It's not pausing. Okay, sorry about that. I did write something down wrong. This wasn't negative 3x. This is minus 30x, which would have made that negative 30x, which would have made this minus 30x. I was not remembering this 253, so Okay, so that means I subtract, or I add 30x here, I add 30x here, and now things should be okay. So negative 30x squared, this and this would make 280x minus 490 equals 0. You want to plug all this into the quadratic formula? I don't. So notice we'll go into all of these, for sure 10. So if I divide all these by 10, I'm going to get negative 3x squared plus 28x minus 49 equals 0. I'm not going to spend time factoring this. This is my A, this is my B, this is my C, and this is where your quadratic formula comes in awfully handy. So negative B plus or minus the square root of B squared minus 4 times A times C all over 2A, which would be negative 6. Now this is a mess. But I'm going to clean it up. So negative 28 plus or minus 28 squared is 784. Give me a second. A negative times a negative times a negative is negative. I can't do that in my head, so give me a second. Okay, so that would be 588 all over negative 6. I'm going to get myself some space here, so let's go ahead and use this space right here. So fortunately, this turns into 196. So I get negative 28 plus or minus the square root of 196 all over negative 6. The reason I said fortunately is that's actually 14 all over negative 6. Now watch this. Negative 28 plus 14 is negative 14 all over negative 6. Negative 28 minus 14 is negative 42 all over negative 6. Now this is just 7. This ends up being, I'm going to take those negatives out, because a negative divided by a negative is positive, reduce it to 7/3, which is about 2.3 or 2.33. And so, as you can see, my intersection point right here is, I'll make this 2.3 comma y. This one right here would be 7 comma y. Now, they're not asking us for anything but what is the ticket price that's required in order to have the revenue exceed the cost of putting on the concert. So it'd be $2.3 or $7. Interestingly, you can figure out where can you maximize your profit too. So that would be an interesting question. Just throwing that in there. It'd be right in here, which is kind of fascinating. But I guess, if you have a perfect sweet asking price for the ticket, you would maximize your revenue. If you ask too much, less people will go. If you ask too little, you're not generating enough money. So a lot's going on with this little story problem. So it's good stuff.